everyone, myself Lakshmi. I am here to explain about our project Design a Music Recommendation System using clustering techniques based on user preference. These are my team members. These are the contents: introduction, methodology, implementation, and conclusion. Introduction. Project overview. In this project, we aim to develop a music recommendation system that personalizes song suggestion for user based on their listening behavior and preferences. Instead of using traditional collaborative or content-based filtering, we apply clustering techniques, specifically K-means clustering, to group users with similar musical tastes. Each user is assigned to a cluster based on features such as preferred genres, artist choose, song interaction history, and listening patterns. Once clustered, the system recommends songs that are popular or highly rated within the same user group. Next will be continued by Arshita.
What is music recommendation system? A system that suggests song to the user based on their preferences and listening history. Why clustering? Clustering allows us to group users with similar preferences even when explicit ratings or history are limited. Project goal: to build a system that recommends using clustering techniques and evaluates its effectiveness through a user feedback and engagement. Next will be continued by Likit.
Methodology. Step 1: Data collection. Gather user behavior and music preference to build meaningful user profiles. Collections data includes genre, artist, language, durations played, users interactions like skills, skips, replays. And step 2: Data processing. Clean and transform data for effective clustering, like handling the missing values, replace with defaults or use techniques. Encoding categories data, genic, artist, language, normalizing listening frequency, normalize play, count, skip, ratios and replace, count using minimum, maximums or z-score, normalizations to bring all values into scale. Step 3: Clustering techniques. Algorithm. K-mean clustering. Determine the optimal K used to allow the method. Clustering strategy. Groups user into cluster based on their normalized and encoded listening behavior. Each cluster represented group or users with similar musicals and behaviors. Step 4: Recommendation logic. Cluster based recommendations for given user identify their clusters and recommended top songs from that cluster, most played, liked or replaced songs. Engagement based ranking. Rank recommended song based on their engagement metrics such as skip rate, replay count, like ratio. Next will continued by Shreya.
Implementation. We are using a tool Python, backend flow, load and clean dataset, create features vectors for each user, apply k-means clustering to segment users, assign new users to clusters based on features, recommend song frequently liked in the users cluster. Evaluation. Collecting user feedback like likes or dislikes and their opinions about our song recommendation. Engagement metrics like listening time and skipping rate. And next conclusion will be explained by Nisha.
Conclusion. Clustering techniques successfully grouped users with a similar music preference. The system improved recommendation relevance without requiring ratings. Evaluation through feedback and engagement showed promising results. The model is scalable, interpretable and effective for a cold start users. Future work includes a real-time learning and hybrid models with the audio features. Thank you.
Here is the code explanations. Import pandas as PD, import numpy as npy. Pandas for handling the structured data like tables, numpy for numerical operations and random number generations. NP random seed 42 sets a random seed so that the generated randoms numbers are reusable every time you can run the code. Num song per genre 100. Set how many songs to generate for each genre. 100 songs per genre. Genres is equals to pop, rock. Define the list of genres for which data will be generated. Data. Initialize an empty list to store the generated songs data for genre in genres. Starts a loop over each genre in the list top, rock, like. For I in range, num song per genre. For each genre loops 100 times to generate 100 songs. Inside the inner loop, For pop song generates, tempo from a normal distributions with mean 120 BPM and STD deviations to energy around 0.85 with small variation, danceability around 0.8. For rock song generates, tempo around 140 and energy higher at 0.95, danceability lower at 0.6. Next will continued by Arshita.
Else. This is a else part of a condition block like if genre equals to pop, if genre equals to rock, etc. It assumes that the genre is gas if a previous condition aren't met. Tempo equals to np dot random normal 100, 2 generates a random tempo using a normal distribution. Mean equals to 100, standard deviation equals to 2. Tempo of gas songs is centered around 100 bpm with a slight variation. Energy equals to np dot random dot normal generates a random energy value for gas. Mean equals to 0.5, deviation equals to 0.03. Energy reflects how intense or active music is. Danceability equals to np dot random normal 0.55, 0.03 generates a random danceability score for gas. Mean equals to 0.55 generates moderately danceable music. Data dot append creates a row of a data, song name, tempo, energy, danceability and genre. If genre song high plus 1 dynamically names the song example gas song 1, adds this row to the data list. df dot pd dot data frame columns song name, tempo, energy, danceability, genre converts the data list into a pandas data frame. Assign properties columns names. df tempo equals to df tempo clip 50, 200 ensures all tempo values are within range of 50 to 200 bpm. Clips prevents breaking analysis. Clips energy and danceability values to range 0 and 1. This is an important since these features are normally scaled between 0 and 1. df to csv synthetic music database index equals to false. Saves the data frame to a csv file named synthetic music dataset.csv. Index is equals to false, omits the data frame index into the file. Next, print high quality synthetic music dataset.csv generated. Print a successful message confirming the dataset has been created. Next will be continued by Shreya. Let the user know file was created successfully. Next will be continued by Lakshmi.
Here we are importing pandas for data frames and numpy for numeric operations and fixes randomness for reproducibility. We are defining a 100 samples per genre and initializes an empty list to collect the data and generates a pop songs with the average tempo 120 BPM and high energy and high danceability, tight Gaussian distributions, and rock higher tempo, very high energy, moderate danceability. For a jazz lower tempo, lower energy, fairly danceable. Here appends the song features and labels to the data list. Converts the list into the pandas data frame in df is equals to pd dot data frame of data columns. From sklearn model selection, import train. Here we are importing required tools like splitting, encoding, scaling, modeling and evaluation. Here encodes the generic strings into numerical labels. X is equals to df defines the features of x and the targets of y. And next to x train, y train, x test, y test train is equal to test train split x y, test size is equal to 0.2, random state is equal to 42, strategy is equal to y. Splits the data into training and testing sets and preserving the label balancing. And the scalar standardizes the features for better model performance. CLF trains a tuned random forest with 200 trees and maximum depth of 10. And next code will be continued by Shreya.
The trainer classifier CLF predicts the genre label for the scale test dataset X test scaled. Calculates the accuracy by comparing predicted labels Y pred with true labels Y test. Print the model test accuracy as a percentage rounded to 2 decimal places. Uses the model to predict genres for all the songs in the dataset df based on the features tempo, energy and danceability. These features are scaled before prediction using the same scalar used during training. Converts the numeric predicted genre labels back to their original string form. Example pop rock using the label encoder LE. Defines a function to recommended similar songs. Takes the input song name the data frame df and the number of recommendation n. Check if the song exists in the dataset. Returns a message if the song is not found. Retrieves the prediction genre of the input song. Filter songs that belong to the same genre but are not in the input itself. Returns the top n recommended songs showing selected features. Prints a heading for the recommendation output. Calls the recommendation function with pop song 1 and prints the results. Thank you.